Welcome to our AI for Everyone instructional video series. This instructional video series is developed by the American Institute for Professional Training and Development, a nonprofit organization. This educational video series is designed to provide everyone with an opportunity to learn about AI and explore how to benefit from this remarkable technology. The entire series is available to everyone at no charge. My name is Sandy, and I will be the AI avatar guiding you throughout this presentation, where we will be discussing what deep learning is and why it matters. Let's get started. It all started with a competition. The year is 2012. The challenge, a dataset called ImageNet. It included 1.2 million photographs across 1,000 categories. The best computer vision models at the time were getting about 26% of labels wrong. That was considered good. Then a team from the University of Toronto entered something different. Their model, called AlexNet, used a deep neural network trained on graphics processing units. Nobody had ever tried this at scale before. The result? An error rate of 15.3%, nearly half the previous best. The audience of researchers reportedly fell silent. This was a remarkable achievement. Within 12 months, every major technology laboratory had pivoted to deep learning. The modern AI race had officially begun. So what is deep learning precisely? Here's a definition. Deep learning is machine learning using neural networks with many layers, deep enough to automatically learn complex hierarchical features. That last part is the key. The word automatic is doing a lot of work here. Traditional machine learning required humans to manually identify what features to look for. If you were building a cat detector, you'd have to tell the system, look for pointed ears, look for whiskers, look for fur patterns. Deep learning eliminates that step entirely. Using deep learning, you just feed it raw pixel data, and the network discovers its own features automatically at every level of abstraction. Think of it like a detective. Traditional machine learning gives the detective a checklist of clues to look for, while deep learning lets the detective develop their own investigative instincts by studying thousands of solved cases until they can spot guilt in ways that no one explicitly taught them. The contrast between the two worlds, before and after, deep learning is remarkable. Let's walk through it. Image recognition. Before deep learning, a 26% error rate was state-of-the-art. After, only a 3% error rate, which was even better than most human performance. Speech recognition. Before, you needed painstaking acoustic model tuning for each language. After, with deep learning, near-human accuracy across more than 100 languages. Translation. Before, rule-based systems that produced grammatically awkward output. After, transformer models producing fluent, context-aware text. And perhaps most telling is the pace of improvement. Before deep learning, progress was incremental. It was years between meaningful breakthroughs. After, new capabilities began emerging every few months. And that pace has only accelerated. Deep learning didn't come from nowhere. 3 ingredients had to arrive together, and in the 2010s, they finally did. First, it needed massive data. The internet provided an ocean of labeled images, text, audio, and video that had never existed before. Without data, networks simply can't learn. With enough of it, they can learn almost anything. Second, powerful GPU compute was needed. NVIDIA's graphics cards, originally designed to render video games, turned out to be perfectly suited for the matrix mathematics inside neural networks. Training time dropped from years to days, then eventually only hours. Third, better algorithms were required. Techniques like dropout, batch normalization, and ReLU activation functions made deep networks train reliably for the first time. AlexNet in 2012 gave way to ResNet in 2015, then the Transformer in 2017, when all 3 combined. The deep learning explosion happened. It's like rocket fuel, a rocket engine, and guidance software all coming together. You need all 3 simultaneously for the launch. Each of these 3 ingredients continued getting better through the 2000s, but it took until the 2010s for them to align. Let's trace the decade of acceleration. AlexNet in 2012, followed by generative adversarial networks, which were invented in 2014. Then, in 2017, Google published a paper titled "Attention is All You Need," introducing the transformer architecture. Many researchers consider this the most important AI paper of the last decade. The GPT-3 was then developed in 2020, 175 billion parameters showed that simply making a transformer bigger kept producing remarkable new abilities. Then, in November 2022, ChatGPT was released. 100 million users in 2 months. Deep learning had entered daily life for everyone. What made the transformer so powerful was attention. Instead of reading text left to right, processing words in sequence, a transformer looks at every word in a sentence simultaneously when deciding what each word means. It processes context in parallel, making it dramatically faster and more capable than anything before it. GPT, Claude, Gemini, DAL, every major AI system you interact with today is a transformer descendant. Deep learning now touches almost every domain. Large language models like ChatGPT, Claude, and Gemini use deep transformer networks trained on hundreds of billions of words. Image generators like DALL-E and Midjourney use deep diffusion networks to create photorealistic images from text. Deep networks are cutting years off drug discovery timelines. AlphaGo and AlphaStar mastered Go. Chess and StarCraft at superhuman levels are all using deep reinforcement learning. Google Translate processes 130 languages simultaneously with transformer-based deep learning. And GitHub Copilot writes working code from plain English descriptions. Here are our 3 key takeaways. Number 1, deep learning is machine learning with many layers that learns features automatically. No handcrafted rules required. Number 2, 2012 was the turning point. AlexNet halved the error rate in one result, and within a year, the entire industry had pivoted. Number 3, the transformer architecture from 2017 is the foundation of virtually all modern AI. Its attention mechanism is what gives language models their power. Thank you for watching. I look forward to seeing you in our next video, where we will explore what a foundational model is and discuss the conceptual breakthrough that made GPT, Claude, and Gemini possible.